Hi everyone, welcome back. So GFG problem of the day today is minimum cost path. So we are given a square grid of size n, each cell of which contains an integer cost that represents the cost to traverse through that cell. We need to find a path from the top left cell to the bottom right cell by which the total cost incurred is minimum. So from the cell ij we can go to the previous column to the next column to the previous row same column and to the next row same column, means top down left and right. These are the four directions we can move, four neighbors, and we have to find the minimum cost path from the top left to the bottom right cell. So this is what we have to do. So the first approach that comes to our mind is the recursion. We can use that, but the constraints here are till 500, so that will give us TLE, time limit exceeded. So how to do this? First of all, let us see the recursive solution. We can see that. So the recursion is simple. We can make four calls for four directions and get the minimum cost. How shall we do this? We have called our function recursive function fun. We have passed a grid. Initially the row and column are 0, 0. Now if we reach the last cell, bottom right cell, then we have to return its value. Otherwise, if we are out of bound or if we have visited a cell previously, then we have to return a maximum value so that it will never be the minimum path cost. Such a high value we will return. So these are our two base conditions. Now we have to find the minimum cost out of the four calls. So we have kept min is equal to integer dot max value. We have to trace back or do backtracking for our grid. So we will store its value before changing it to -1 means visited. Now after that we will find out the minimum value from the four calls. In four calls we will have four directions, that is row plus 1, row minus 1, column plus 1, column minus 1. After these four calls we will do backtracking, means we will mark the grid to its original value, means we have not visited. This is for backtracking, means for other path we will be having the original grid. And at last we will return minimum plus the value of current cell. So this will be the minimum cost for traversing. This solution is correct, but it will give us time limit exceeded. So this was the simple recursive brute force approach. Now how to optimize this or how to solve this? This is a hard level question, but we will solve it very simply. So just think of this question as a graph question. Now how do we do solve graph questions? We solve using algorithms. And this is minimum cost path, means single source shortest path algorithms. We have the source, that's top left cell, and the destination is the bottom right cell. Then we have four neighbors, and for each neighbor we have certain cost, right? So we can consider the same question as a graph problem. Now if we consider it as a graph problem, our solution becomes very easy. What we can apply, we have different weights. It is a weighted graph, so we cannot use BFS for single source shortest path. What else we can use? We can use Bellman for Dijkstra. There are no negative weights, so we can use Dijkstra algorithm, which is very simple. We will just apply the Dijkstra algorithm and get the single source shortest path, minimum cost path from the top left cell to the bottom right cell. We have already previously discussed some questions involving Dijkstra algorithms. So this too will be the same. We will just apply the Dijkstra algorithm. Now first of all we have four directions which we will get the four neighbors. So we have stored directions for row and columns, that is row and column. If we want to move to the next row, the row will be +1 and column will be remain same, so 0. If we want to move to the previous row, row will be -1, column will remain the same. If we want to move to the next column in the same row, row will remain same, column will be, for previous column, column will be -1, for the next column, column will be +1. So these are the four directions we have stored in a direction array. Now what we want a priority queue which will give us the vertex which we have calculated the minimum cost to. So we have created a priority queue. In the priority queue, what we will store the vertex, that is row and column. In this case, for this grid, the vertex will be row and column, right? The cell will be row and column. And then the minimum cost will be the third attribute. So we will have three attributes: row, column, and the cost to reach that row and column. Now how we have to sort the priority queue and our vertices based on the minimum cost. So the cost is the third attribute, means the second indexed. So we are sorting our priority queue based on the minimum cost. So I1, I2 be two arrays, and how we have to sort them based ascending order based on the cost, that is the second indexed attribute, means the third attribute. So we are sorting our vertices based on minimum cost. Now after that, what we have to do, we have to add source to our queue. So we have added source, row is 0, column is 0, and what is the cost for source? Usually for this Dijkstra the cost for source is 0, but in this case we are adding the cost of that source, that is the first grid 0, 0 is the cost for that cell. So we have added source to our queue. Now we also need a visited array so that we know which cells we have visited and we do not go on a loop, infinite loop. So we will not do the work for visited cells. So we have created a 2D visited array till grid length and grid 0 dot length, means for complete grid we have kept a visited array. Now till when we have to do the work till the queue is empty, we will find out the node, the vertex in front, which is in front of queue, means the minimum cost vertex for which we have got the minimum cost. Now our row is the F0 element, our column is F1 element. Now what we have to check, for this row and column we have got the minimum cost. Now we will check if it is equal to the bottom right cell, means grid r is equal to grid dot length minus 1 and column is equal to grid 0 dot length minus 1, means the bottom right cell, means we have reached our destination. If we have reached our destination, we will just return the cost to reach that destination, which is stored in F2, right? Now if it is not the destination, we will check. If it is visited, we will not do the work again. For that we will just continue. If it is not visited, we will mark this row and column vertex as visited, means true. We have marked it true. Now what we have to do for this vertex, we have to add its four neighbors to our queue with their cost, right? This is what we do in Dijkstra algorithm. So our four neighbors will come from the directions. So we have taken each neighbor direction from directions, calculated the new row and new column. They will be current row plus the row direction and the current column plus column direction. So we will get new row and new column. Now one thing we have to check is that the neighbor should be in the grid. It should not be out of the grid. So we will check. If it is out of the grid, we will leave it. And when it will be out of the grid, if new row is less than 0 or new row is greater than equal to grid dot length, or column is less than 0 or new column is greater than equal to grid dot length, means it is out of bounds, so we will just leave it. Otherwise the coordinates are valid, so we will add them to our queue. So we have added a new array to our queue, that will be new row and new column. And what will be the cost to reach this? The cost to reach the parent plus the cost to reach the current row and current column element, that is grid nr nc. So this is the cost to reach this cell. We have added this cell to the queue, and if we have a path from source, which we will definitely be having from source to destination, this while loop will definitely return the minimum cost path. If there is no path, our Dijkstra algorithm returns -1, that is, we did not find any path. But this condition will never arise in this question. So this was the simple solution using Dijkstra algorithm. I hope you guys would have got the idea. Thanks for watching the video. Have fun. Bye.